Hi everyone. Today we are going to discuss this problem which is common yet peculiar and present in almost every mathematics channel in YouTube, that is 3 to the power x equals x to the power 9. Now ironically, first we are going to solve this problem and then we are going to question, is this really solvable? Let's first discuss this simple problem, that is 3 to the power x equals x to the power 3. So we'll divide the exponent by 3x on both the sides and obtain 3 to the power 1 by 3 equals x to the power 1 by x. And we can easily see that x equals 3 is a solution. Now we'll come to our main problem, that is 3 to the power x equals x to the power 9. And we'll divide the exponents on both the sides by 9x to take the constants on one side and the variables on one side and obtain 3 to the power 1 by 9 equals x to the power 1 by x. Now we can't see here clearly that what is the solution. So we need to make some manipulations here. Now we need something of the form a to the power 1 by a, and in order to do so we raise 3 to some power k and multiply k with the denominator of the exponent to neutralize. On careful observation, we see that k has to be some power of 3, so we write it as 3 to the power alpha. And the expression becomes 3 raised to the power 3 to the power alpha raised to the power 1 by 9 times 3 to the power alpha. Now, we want the base and the denominator of the exponent to be equal. Thus, we write 3 to the power 3 to the power alpha should be equal to 9 times 3 to the power alpha. Or equating the exponents on both the sides, we can say that 3 to the power alpha equals alpha plus 2. In our exponents video, we learned to solve such problems using graphs. So we'll plot the graph of y equals 3 to the power x and y equals x plus 2. And we see that the solution might be x equals 1. So we put x equals 1 and we see that y equals 3 for 3 to the power x and y equals 3 for x plus 2 as well. So x equals 1 is clearly a solution. So we go back to our equation and substitute alpha equals 1 and obtain 3 to the power 3 raised to the power 1 by 9 times 3, which is equal to 27 to the power 1 by 27. Now we can clearly see that x equals 27. Now wait a second, did we miss something? Let's go back to the graph of 3 to the power x and x plus 2. And we see that there is a second point of intersection. So what about this problem? It might be that 3 to the power, this negative quantity is also a solution. To answer this question, let's go to the graph of y equals x to the power 1 by x. And we'll discuss how we got this graph at the end of the video. We see that there is a peak and the peak occurs at x equals e, which is Euler's number. The graph actually goes to y equals 1 as x tends to infinity. And if we plot x equals 27 on the graph, then we get y equals 27 to the power 1 by 27. And drawing a parallel line to x-axis, we see that the graph intersects this line at another point. And this point can only be determined numerically and no analytical or arithmetic operation exists to find such points. The x coordinate of this point is going to be 1.1508 something something, some irrational number. And I use this binary search code to obtain the solution. To plot the graph, we will write the function as y equals x to the power 1 by x, which can also be written as e to the power ln x by x. At x equals 0, the function is not defined. So we use limit x tends to 0, e to the power ln x by x. And we see that it's of the form e to the power minus infinity by 0. So we get e to the power minus infinity, which is actually equal to 0. As x tends to infinity, we get limit x tends to infinity e to the power ln x by x. And we use L'Hopital rule to differentiate the numerator and the denominator of the exponent. And we get e to the power 1 by infinity, which is equal to e to the power 0. Next, we are going to differentiate this function and obtain this complicated looking expression. And we see that the only part that is going to be negative is 1 minus ln x after x equals e. And before that, it's going to be positive. So function y increases till x equals e and then decreases. So we obtain x equals e as the maxima. Thank you so much folks for watching the video till the end. If you like, please subscribe my channel, and if you have any comments, please post it below. If you have any questions, do post it below. Thank you again so much for watching.